discuss about differential equation. First of all, an equation containing derivative of one or more dependent variables with respect to one or more independent variables is said to be a differential equation. For instance, differential equation can be classified into three. First, we can classify it by type, and then order and linearity. Differential equation can be classified into two types. First, it can be called as ordinary differential equation or ODE. Second is partial differential equation or PDE. Today, in this video, we are going to discuss about an ordinary differential equation only. Equation contains only ordinary derivative of one or more dependent variables with respect to a single independent variable is said to be an ordinary differential equation. Here is some example of ordinary differential equation. First, dx over dt plus dy over dt equals to 2x plus y. Next example is dy over dx plus 5 equal to exponent to the power of x. Second is classification by order. We can take the highest derivative order in the equation. For instance, this is second order of differential equation because it is to the power of 2. Another one is dy dx because we can only 2 in the bracket, so it is known as first order differential equation. The last one is classification by linearity. An ODE is said to be a linear if f is linear in this form, or we can generalize it as into this form. There are two properties of linear differential equation. First, dependent variables and its derivative are of the first degree. That means it is the power of each term involving y is only 1. And second is each coefficient depends at most on the independent variables x. For instance, this is an example of linear DE. What are the properties or characteristics of ordinary differential equation? Here is existence of a unique solution theorem. So, we let R be a rectangular region in the xy plane defined by x between A and B and y between C and D that contains the point x0, y0 in its interior. If f(xy) and partial f over partial y are continuous on R, then there exists some interval I0 x bigger than x0 minus h and smaller than x0 plus h. H must be bigger than 0, contained in at x-axis between A and B, and a unique function fx defined on I0 that is a solution of the initial value problem, that we can solve dy over dx equal to fxy subject to yx0 equal to y0. Let's discuss about the solution of differential equation. Some differential equation or DE can be solved by the method of variable separable. Okay, this method is only possible if we can write the differential equation in form A dx plus dy dy equal to 0. Once we can write it in the above form, we can integrate to obtain our general solution. Okay, notes. This variable section, we only deal with first order only. Okay, so this is differential equation that we can solve by separable variable. Okay, we can move the exponent to the right hand side and left the dy dx at left hand side. Okay, let me show. Dy dx equal to negative ex plus y. Then we can separate the exponent to the power of x. Exponent to the power of x dot exponent to the power of y dx. Let y term together at left hand side and x term be on the right hand side. So 1 over exponent to the power of y dy equal to negative exponent to the power of x dx. And we solve it. Exponent to the power negative y dy and negative exponent to the power of x dx. And then we can continue to simplify the integrate. Y dy equal x. And then let negative y as u, and then du over dy equal to negative 1. And divide du by negative 1 and negative 1 dy also divide by negative 1. That negative 1 du equal to dy. And then we solve the integrate. Du equal to negative exponent to the power of x dx. Then we solve the integrates. Then we solve the integrate until we get the general solution. So for this example, this is our general solution for DE. And there are a few methods in solving differential equation. First is numerical method, and then Range-Kutta method, hybrid method, linear multi-step method, and next is general linear method. As we discussed before this, there is a method of using numerical method, and in this video we will talk about Euler method, which it is under numerical method also. To generate a numerical solution to an initial value problem of the form y prime equal to f x y and y x naught equal to y naught, we decide upon what interval starting at the initial condition we desire to find solution. We chop this interval into small subdivisions of length h. Then, using the initial condition as our starting point, we generate the rest of the solution by using the iterative formula, which is the formula is xn plus 1 equal to xn plus h, and another one is yn plus 1 equal to yn plus h f xn yn. To find the coordinate of this point in our numerical solution, we terminate this process when we reach the right end of the desired interval.